This is problem number 92 of the 2012 AP Calculus exam. Let R be the region in the first quadrant bounded below by the graph of y equals x squared and above by the graph of y equals the square root of x. R is the base of a solid whose cross sections perpendicular to the x-axis are squares. What is the volume of the solid? Well, let's begin by looking at the graphs of y equals x squared and y equals the square root of x in the first quadrant. Now this is a graphing calculator section, so let's just go ahead and use our graphing calculator. We'll clear it and go to y equals, make sure it's clear, and let's put in x squared. Now we already know that it looks like a parabola, but we'll go ahead and put it in the graph. And we also have the square root of x that we know looks like a parabola on its side, the top half, since it's positive. But we'll put it in the calculator anyway and look at those graphs. All right, let's zoom in a little bit. And let's go ahead and pull that off the screen and look at that. So we're only looking at the information in the first quadrant. So we're looking at this part and this part. And this is our region R that they're referring to. The region in the first quadrant that's bounded by those two functions. Now, we need to know where do they intersect. We know that's at 0, but what would this point? Now, it looks like it's at 1, but let's check it. Pull up the graphing calculator, hit second and calculate, intersect for number 5, and first curve, second curve, and again, I'll guess this first one. We think it's 0, but we want to make sure, so hit enter again. And that is true. So we have an intersection first at 0. And let's look at the second one. So we have second and calculate. Number 5 for intersection. First curve and second curve. And let's go a little closer to the point of intersection we're looking for. And hit enter. We see that that's at 1. And that's what we expected. All right, so 0, 0, and 1, 1. So, next. If I'm looking for a volume whose cross sections are perpendicular to the x-axis, then we're going to have this in terms of x. Since those cross sections are squares, we'll have the following setup. We'll have the volume as being equal to the integral from 0 to 1, we've just found those limits of integration, of the top function, which is the square root of x, minus the bottom function, which is the x squared, and since it's squares, we're going to square that quantity. Okay, and that's going to be our volume using cross sections. Now we've got to put it into the graphing calculator and solve, and we'll be good to go. So let's go ahead and pull that up. Let's clear this. Let's go to Math and 9. And I want a parentheses because I've got this quantity, and I've got the first one I think I put in was the x squared. So let's go to variables. And the second one I think I put in was the square root of x. So I'm going to go to variables, but I want to use the second one first. And then minus, and then the x squared was y sub 1. So variables, and y sub 1. I want to put a comma, and an x, and a comma, and 0, and a comma, and a 1 for my limits of integration. Let's clear that. Let's try that again. I forgot the square. One more time. So, Math 9. And we're going to have a parentheses and variables. Go to y variables, function. Now, my square root of x was the second one that I entered, so I want y sub 2. Minus variables, y variables, function, and y sub 1. And I want to go ahead and close the parentheses here and square it, and then put my comma and my x and my comma and the 0, comma, and 1 for my limits of integration, and close that second parentheses, and now I'm good to go. And before, I had forgot to put that parentheses in the square. So let's go ahead and hit enter. And this will be our volume. We can round that to 3 decimal places. So I'll have my volume as equal to 0.129. And let's go ahead and look. That's answer choice A. I hope that helps.